Hey, this is Terry, and in this video I want to talk about the A35.8 amplifier. Now, there's a lot to discuss, and I'm not exactly sure even how to begin, so let's just start with the basics. It's an 8-channel amplifier that produces 150 watts per channel, all channels driven. Each pair of channels can be bridged so that not only can you create an extraordinarily powerful single channel, it also means that with various combinations of bridged and unbridged channels with the A35.2, you can pretty much create any combination of amplification you might need to drive virtually any surround sound speaker array, as well as produce one of the most powerful 2-channel bi-amplification amplifiers. Now, let's start with the fundamentals, and that is always in our designs, the power supply. And in this case, this is the most powerful power supply we've ever built. And in fact, what it does is allow this amplifier to produce 1,500 watts of total power. So, with this power supply designed as a soft clipping APFC, auto power factor control supply, it means that we've reduced the noise to virtually zero from this power supply. Not completely, but to a degree that it is essentially as quiet as a switch mode supply can get. Then, to make sure that that power is delivered most efficiently and directly to the 8 amplification modules, there are 2 bundles of wire that connect to a block of 4 modules, and then the remaining 4 modules. This gives us a shorter power path, and therefore the ability to deliver that power more directly and consistently as the modules require it. Now, those modules are Hypex N-Core modules, and they're fitted into these heatsink assemblies. And the beautiful part of the engineering design that Bent Nielsen did in combination with our team of consulting designers is that these modules essentially slip into the amp itself, connect with a multi-pin connector, and then are held down with 4 bolts. This means a couple of different things. One, it allows for field service, meaning that if you have a module or a pair of modules that goes down, we will be able to send you a pair of modules, and you'll be able to simply remove them and insert them with ease. The other thing that this does is that it allows for the shortest possible signal path, meaning that in the circuit board here, you will see that there is just a small little vein of board that goes in through this little channel under the heatsink, so that any input that comes in this side goes simply to the amp module and directly out through the speaker binding post with the shortest possible signal path. Now, the other thing that these modules do, which is quite interesting, is that they provide a certain level of shielding. So we talked about how low noise this power supply is, but no power supply is completely without noise. And so the heatsink here essentially shields the amplifier module here from any noise the power supply might generate. And on the opposite side of things, the heat shield here isolates the input section and the output section from any noise the amplifier module might create. And so as these heat sinks essentially go down through the spine or the center of the amplifier, they provide a certain level of shielding that otherwise the amplifier might not have. Now, those heat sinks are also embedded down inside here so that these screens are open at the bottom to allow air to vent up very effectively through the heat sinks. And in such a compact box producing that much power, it is kind of an achievement when it comes to the design of the product to make sure that it runs ultra cool. Now, there are some who have become aware that we are using the N-Core module in this design and have expressed some disappointment that we aren't using UFPD or UFPD2. And this may be one of the prime examples of our practical design approach. We don't really do anything for marketing purposes. We always weigh in the balance what the technology or the component part can provide in the way of performance versus its cost. And always with the idea of reaching our goal of providing the best possible experience for the greatest number of people. And as we began to look back on our experience in producing multi-channel amps, whether they're 3, 5, 7, whether they're Class A, B, or using Class D, we recognized that the costs of miniaturizing, say, a UFPD2 module like this, in order to be able for it to fit into a heatsink module like this, would raise the cost of the amplifier while not necessarily delivering the level of performance benefit you might expect for that added cost. Now, there's a reason for this. We still believe that UFPD, UFPD2 is the best sounding Class D module out there. However, Class D is such a strict discipline that there are really only so many ways in which you can improve the basic design. So strict is the discipline that if you don't get it right, if you don't get the math just right, it just won't work. And in fact, a lot of companies are unwilling to go to that expense, go to that engineering level. And therefore, some of the Class D sound you may have heard in the past is an example of that, where it just hasn't been successful. But for all of the better designed modules, say Patrick Bostrom, our amplifier consultant that's now Chief Technology Officer over at Ice Power, or Bruno Putzis with Hypex, who did the Encore here, they know that there are certain things that you can do to make Class D as good as it possibly can be. And one of those is higher oscillation frequencies. So 300 megahertz here for the Encore, 300 megahertz in UFPD. UFPD2 has 500, Bruno's new Eigentalk has 500 as well. And then you also use a global feedback loop that really allows for complete control so that your output impedance is as low as possible, so that like our amplifiers, we can confidently drive a 2 ohm load. And then, by having that higher oscillating frequency, you're able to sculpt or mold or create output filters that really allow for this linear amplitude across the audible bandwidth that means that they have this natural neutrality with this ultra low noise and the speed of delivery because of the efficiency of the Class D design that really is quite remarkable. And so to a great extent, the design efforts done here are very similar to our own UFPD. And as a result, when we're using things even like the smaller Hypex modules that we use in the 15 series, we get a sound so close to the UFPD, UFPD2, that Primare sound, that natural, neutral sound, that sometimes people have a difficult time telling the difference between, say, an I-15 and an I-25. And often you have to do cross comparisons for them to understand that the larger amplifiers, the I-25, I-35, A35.8, just increase the soundstage size and the details within that soundstage, and the three-dimensional kind of reality of that presentation just gets greater and more effortless as you go up in the line. But ultimately, the tonal timbral characteristics remain true to what we are looking for in the sound of our amplifier. The other advantage that the Hypex Encore module provides is that they are produced in much larger quantities than we will ever have need to produce UFPD or UFPD2. And therefore, for the same level of quality of design, quality of construction, we actually have a considerable reduction in overall costs due to these economies of scale. So as a result, we're able to use these most effectively and keep the cost of the amplifier down. This will retail for €5,000. We had hoped to make it lower, but current circumstances mean that parts costs, shipping costs, every cost is just more and more expensive. And so with that in mind, we were able to create these wonderful little modules, and Ben did a really interesting trick with this. This is a standard Encore module, and if you take a look at it, you can see that it has this kind of aluminum base plate, which actually acts as a partial heat sink. But Ben realized that if we removed that metal plate, and that there are components attached to it, and put those directly into the heatsink, attach them directly into the heatsink, we would get greater energy transfer, better thermocoupling between the amp modules and this heatsink, again, to improve the overall performance of this module, and as a result, improve the overall performance of the amplifier. So the power supply, the most powerful we've ever made, is driving these wonderful modules in this incredibly well-designed architecture, so that you get amazing sonic results, and sonic results that really allow you to configure the amp as you need it. So there's also some discussion about how many channels of amplification we would provide. In this day of immersive audio technologies, of object-oriented sound mixing, Gone are the days of the channel mixing where you essentially have to, as a sound engineer, kind of adjust levels and gains to try to create the phantom center images among the 4 stereo images that you have in a surround sound system, and that by equally hitting all 4 of those basic speaker elements, you could kind of create a sense of height. All of that is gone now. You have these computer-controlled mixing panels where you can essentially, a sound designer, can essentially put a sound wherever they want to in the sound field. But that also means that with this level of flexibility, there are so many different channel combinations. 5.1.2, 7.1.2, the list goes on and on and on. So do we do a 3, a 5, a 7, 9, 11, 13, 16 channel amplifier? So what we hit on was 8 channels. In part because this could be used in a more conventional, maybe even you might say old-fashioned distribution amp profile where you've got wired connections to pairs of speakers throughout the household. But more importantly, with the bridged aspect of this amp, we can create mono channels, we can create having stereo channels from the various modules, and really be able to do any combination you want. So the classic combination, let's say a 5.1 combination with this, is that you would simply bridge 3 pairs of channels to create your left, center, right array, and then use the remaining stereo pair for your rear channels. Or if you have a 7.1 system, you would simply bridge only 1 of those pairs of channels to drive your center, and the rest of the stereo pairs would be able to power then the remainder of your speaker array. But it's with the introduction of the A35.2 into the mix where things become really interesting. Because what you can do then with this, and this is the configuration I'm using, is you can take an A35.2 for your left and right main speakers, bridge a pair of channels for your center channel, bridge 2 pairs for your rear channels, and then you have the remaining stereo pair for height speakers. Now, the number of combinations goes on and on and on. In fact, there's the kind of high-powered version of the one I just described, but that's where you use 3 mono-blocked A35.2s for your left, center, and right front array, and then the rest of the amplifier modules in an A35.8 fills in all of the other speakers you might have in the system. Or you use 2 A35.8s for an Oro 3D system. In any case, we could go on and list the number of different combinations that are possible with this amp and with the bridging capability, but it might be best for you just to go to the website, the A35.8 page website, and be able to take a look at all of the details, all the features, all the functionalities that are part of this really remarkable multi-channel amp. But I almost forgot to mention my favorite combination. And that is bi-amping with a bi-wire pair of speakers and a single A35.8. With this amp, you can bridge all 4 channels, all 8 channels, so that you have 4 channels of amplification, and then you take 1 channel to drive the upper frequencies, another channel to drive the lower frequencies of your left speaker, and then the other channels to drive the upper and lower frequencies of your right speaker, and you have what is in effect a 1500 watt stereo bi-amp configured amplifier. So, I'm sure I've forgotten other things as well, so go to the website. Or if you have questions, fill out a help request form in our help center. There's an FAQ there as well. And with the thought that we will get back to you and answer those questions as soon as we can. And finally, obviously, follow us if you like these kind of videos, and click a like to let us know that this was helpful. Thanks.